This is 9.3 statistics for performing what we call as a hypothesis testing and confidence interval for two depending samples matched pair for mean. So in question 2, before we do question 2, it says that for question 2 and 3, assuming that pair sample data are a simple random sample, there are differences have a distribution that is approximately normal. Again, the reason why they give us this assumption is because you do not need to check the requirement. So when you have this assumption pop in your test or in your homework, that means you do not need to check the assumption in this case. The reason why is because if you look at the assumption, it says that there are dependent simple random sample where that's the first two requirements, and the sample data is large enough or approximately normal. So in this case, by doing that, so this will actually say that it is a pair sample data which is dependent, and it is simple random sample, and it is approximate. So this gives us these three requirements for requirement check, so you do not need to check it. So again, in your test, make sure you read this. If this assumption is not there, you have to check your requirements. So question 2 says that as a part of the National Health and Nutrition Examination Survey, the Department of Health and Human Service obtained self-reported heights for measure heights for males aged 12 to 16. All met are in inches. Listed below are the samples in this case. So use a 0.01 significant level test to test the claim. So this is a claim, testing the claim here, that there is no difference in the self-report heights and the measure height. So why, this is a 2, and this is mean because we are using mean in this case. Why that is, why we're going to using the 9.3 here instead of 9.2. 9.2 is independent, this is match pair. The reason why that this is a 9.3 is because the reported and the measure are come from exactly one person. And that means this one person given us two data. One is being reported and one is being measured. So this is called the depending samples or independent samples. So this is going to be in 9.3. So this is where the match pair comes out. Or in other words, here you have to use mu d. So this is how we figure out that the difference between 9.2 and 9.3 is, are they independence or are they dependence or match pair in this case. So this is a match pair, we use mu d. So in order for us to perform a hypothesis testing, you have to write the null and the alternative. Now the null hypothesis in this case is no longer mu1, mu2, p1, p2. It's going to be mu d. Okay, so in this case, you have to use mu d is equals to 0. And that is the null hypothesis. And you're going to test against the alternative, mu d in this case. Based on your hypothesis testing, it said there's no difference. No difference means it's not equals to 0. So for hypothesis testing for this kind of test, you always use 0 for this case. Okay. So what is the sampling distribution? That's the second step, is asking for sampling distribution. Again, this is mean, so the sampling distribution is a t distribution. Z distribution is used if it's for proportion. And then now we're going to use R in this case. So how do we use R in this case is we will have to enter all this data. So usually the report data is my X, and the measure data is the Y. So I can tell you that if you read this question, it says that the difference between self-reported height and measure height. So you find out that the self-reported height comes first. So that comes first means that is your X, and the measure height comes the second. So that's why the measure height is your Y. So make sure you guys understand that this claim statement, because if I interchange these two, then your X and Y here has to be interchanged. And when you interchange your X and Y, then all your answers will be wrong. So that's the reason why that you have to read this question carefully, that this is your X and this is your Y. So you put this in your X, in your R, X equals to C and Y equals to C. So in order for us to find the difference, we use D. D equals to X minus Y. So it's always X minus Y, which is the difference between the two. And this D is actually all this difference between 68 and 61.9, 71%. So it's a difference between those numbers. So you got all these numbers, and this is listed under D. So how do we use your R to test the claim? So if you look at your yellow index card, or you look at your notes, again I highlight here, there are two. One is in blue and one is in green. Blue is used when you use confidence interval. Green is used when we do a hypothesis testing. So for this question, we are using hypothesis testing. So we're going to use the t-test. So mostly of this is t-test. D is what we're going to use. Mu equals to 0. Alternative is equals to two-sided. In this case, is two-sided. So we're going to use exactly the same syntax here. So we're going to copy and paste here. This is the syntax we will be using. So we're going to use t-tests to find your test statistic and your p-value. D is used because these are the value for D, which is x minus y. And then mu equals to 0 because that is our testing value, is always 0 right over here. And alternative in this case is equals to two-sided. The reason why we use two-sided here is because of there is no difference, so that's why we're using that. So you will get this. This is your test statistic here. So your test statistic in this case will give us a t. That's why it's called t distribution. In this case is negative 0.984, and your p-value in this case is given us by 0.3461. So this is how we find your test statistics and p-value, and then the decision comes next. Since your p-value is 3.3461 and alpha in this case is given us by 0.01, so in this case we know that your p-value is greater than alpha, so we will fail to reject your null hypothesis. So we will have to make conclusion in this case. And again, your conclusion is the same conclusion table that we used for chapter 8. So if you look at the conclusion table that we have for chapter 8, where is my chapter 8 conclusion? There you go. This is a chapter 8 conclusion. So does your claim include or not include equality? By looking at your claim statement, let's take a look at your claim statement here. It says that there is no difference. So no difference means, this is a claim statement, no difference means it's equal. So this is your claim statement. And since your claim statements does include equality, so we will using one of this. And look at your decision. Since my decision says that we are fail to reject, so in this case fail to reject, and it does include equality, so your conclusion is number 4, which is there is not sufficient evidence to warrant rejection. So this is how you make your conclusion here. There is not sufficient evidence to warrant rejection of the claim that, now the claim says what? That there is no difference between self-reported height and measure height. So you copy and paste over here. So this is how we perform your hypothesis test, and this is how we do question A. Don't forget this has 2 questions, and now we're going to do question B. So in order for us to do question B is where you perform a 99% confidence interval, and then you have to interpret these results and then comment on the implications of whether the confidence interval contains 0 or not. So how do we find a 99% confidence interval in this case? Is again, we're going to use R. So by looking at your notes here, we are using this time the blue one because there is a confidence interval. We will use t-test, D conf level equals to A. What is a confidence level in this case? The confidence level in this case is 99%. So in this case, we will be using t-test, D, the same D that we use, which is the variable D that we have here, and conf level equals to 0.99. So this is how we gonna do your confidence interval, to find your confidence interval. And the confidence interval is given us by negative 4.15 and 2.15. So don't forget, you need this code, your R syntax here, to get your 1 point. So to get your 99% confidence interval in this case, your answer will be negative 4.156 to 2.156, and again, the units here is miles per gallon. Don't forget, all the units here is miles per gallon. And then the question asking us, how do we interpret the confidence interval? We just did it in question 1C. So this is how we interpret your confidence interval for this case. So I'm going to copy and paste it, and we're going to change a little bit. Oh, this is not miles per gallon. I am so sorry. This is going to be H. This is going to be in pounds. Let me see. No, this is not. This is not in pounds. This is in inches, right? Yep. These are all in inches. Sorry about that. So the unit here is all going to be in inches, not in miles per gallon. That's the previous one. So how do we interpret this confidence interval? So in order for us to interpret the confidence interval that we just used, we are 99 because we changed it to 99% here. Confident that the interval from, we don't use 1 to miles per gallon, it's going to be negative 4.156 inches to 2.156 inches actually does contain the true mean the true population mean difference between, now we just say between what? Between the self-reported height and the measured height. So this is your that's what they want you to find. So it's between the self and the measured reported height. Some of you will ask me about it, say, David, I don't understand why this is negative, right? How can you have a negative inches? This negative inches means it means that the difference, the mean difference between those two can have negative. Means, for example, if you look here, the difference, look at this difference. This is negative difference. And what does it mean by negative difference? Means that the person who report is 63, but actually he is 64.9. So that means that he reported his height shorter than what it's supposed to be. And if you got a positive, means that you actually over-report. That means that you report 71, but actually you are just 69.9. So that means that it can have a positive or negative the mean difference here. So that's the reason why that you can have a negative answer in this case. Okay, and this question also asking us that what is the implementation? Comment what happens when the confidence interval contains 0. So in this case, your interval, it does contain 0 because 0 is between here. So since the CI contains 0, so because 0 is between negative and positive number here. So then you can say that your mu d in this case is actually equal to 0, which is the same thing as saying that your conclusion right here, there is not sufficient evidence to warrant rejection the claim that there is no difference of this. Or in other words, it means that there is no difference of the height in this case. The reason why you make that kind of conclusion here is because the word no and the word warrant rejection is kind of like a anti-negation, so two double negative here, so you can cancel it, you can kind of become positive, so that means you do support your claim here. So what you're talking about these things is, yes, it contains 0, means there's no difference on this case, so it does support what you have in your conclusion you did in part A.